Hi everyone. So I'm introducing myself, I guess. My name is Felix Hupfeld. I'm one of the founders of Quobyte. Quobyte is a storage startup, and I'm going to talk to you about file, block, and object storage with Quobyte, also in the OpenStack context. To wake you up a bit, I thought I'll start a bit interactive. After lunchtime is not always the best time, right? With a quote, software is eating the world. Somebody knows that? No? Okay. It's from Mark Andreessen, one of the Netscape guys and one of the VCs of Andreessen Horowitz. Basically, he's expressing that software is today changing all business models in all industries. And in the end, this trend is the reason why we're all here, right? With OpenStack, software is replacing traditional IT infrastructure. Software is doing that in a large scale with all stuff like virtualization, networking, but also obviously storage. And that's what I'm here for to talk about. There's a lot of new concepts in the new software storage world. It runs on commodity hardware. It's software defined. That's a term you find on every vendor's webpage. Erasure codes, right? Unified storage, Googleize, enterprise storage, end of silos, hyperscale, hyperconverged, fault tolerant, capped theorem, right? Dedupe, or flash arrays replication. These are the concepts, basically, of the new software-based storage world. What we're leaving behind are a lot of technologies that we're familiar with, but that do not translate in the new world and can't also be adaptive to that. Stuff like iSCSI, LANs, fiber channel, dual port SAS, scale-out probably too, RAID replaced by erasure codes or application, thin provisioning, mirroring. My favorite thing, which I just learned, is StoneIt. Does someone know what that is? These are the sockets of HA pairs of filers that can switch each other off for doing a failover, basically. And it's an abbreviation for shoot the other node in the head. I mean, fault tolerance has been there for decades, and that is what fault tolerance was about, right? Have hardware means to do that. In the new world, it's all software. But the new world is not simpler. You always have a lot of question marks, right? You get seeing all these new systems. You don't know what they're actually doing. You don't have your basically preconceptions and drawers where you can put them into and make comparisons. And you have to learn a lot of new things. Question is always, what's the fundamental architecture of the storage system? That's something storage systems can't escape out of, right? If it's an object storage system, it's an object store. You won't do real file workloads or virtual machines on top of it. The actual performance, scalability, that's also something that, open-end when you talk about, but in practice, you have a lot of things about technical scalability, but then also operational scalability. Fault tolerance, fault tolerance has been there for decades, but how fault tolerant is stuff actually? Commodity hardware, what's commodity, right? Some people, they're all flash systems where NVRAM is part of the commodity hardware, which is probably not everyone's definition of commodity. And also, right, software defined, what does it mean in the end? You also find on NetApp's webpage that they're software defined, and I think rightfully so, but it doesn't fit everybody's definition. In my talk, I basically capture those three questions. First, I'll talk about Quobyte, what it is. Then I'll explain a bit how it works. And I took the liberty to do that in a comparison to Ceph, because that's the reference in the OpenStack context that everybody has in their minds. And that would be the question that everybody would be asking anyway, right? So it's hard to explain a storage system here without making reference to Ceph. And then I'll talk about how it integrates with OpenStack. So what is Quobyte? Quobyte is a software storage system. It's a full stack storage system, basically commodity hardware, hard drives beneath it, and then at the top it exports storage services. At the core, it's a POSIX file system. And I think I can claim that together with Ceph, which has a similar history, it's one of the few general-purpose storage systems that's really split brain safe, fault tolerant, and scalable. The split brain safety, fault tolerance, that's the new kind software cap Paxos kind of fault tolerance, where you can plug any basically plug any network cable. Top of rack switches can fail, nodes can be half failing, browning out. Basically everything's handled by software because that's part of the system model that the systems were designed with. And that's also basically the foundation for being able to run systems the way Google is doing it. Basically hands off, no matter what the hardware is doing, it doesn't threaten my data. It can threaten availability, but it will never threaten my data. If you have a block storage system in the old world and the StoneIt sockets fail, right, then you have probably two things riding on the same block device, and then your data is gone. That can't happen in this context. Quobyte doesn't come out of thin air. Basically, we're the ExtremeFS team. We've been doing that since 2006, and also first in a university research context, and now as a company for the last 1.5 years. And basically, that's a similar trajectory like Ceph's origin. Unlike Ceph, the software is commercial. ExtremeFS is an open source parallel file system. This is a commercial product. Software subscriptions, including updates and everything. Commercial doesn't mean it's more expensive, necessarily. So what are the use cases? Basically, when we started with ExtremeFS, we had this buzz in our head, that's how Google is doing their storage with Google File System and Bigtable and things like that. That's when we did the research, we thought, okay, that's what we want to do. And basically, we set out to first say, okay, we want to do a POSIX file system, and it should be run like Google's. And that's what we continue now. Basically, trying to become a horizontal storage system that you deploy in your whole cluster at sizes up to 10,000 nodes, right? Or also on a cluster or like 3, 4, 5 nodes, where it already makes sense. In the end, through the fault tolerance and other hardware aspects, the whole storage service is decoupled from hardware. So it's not relevant whether certain pieces of hardware are up or have been failing or are broken. It's not relevant where the data actually lies, because you can always add resources and things like that. And that simplifies management a lot, and it already simplifies management if you have a couple of servers. In the end, because we're a unified storage system, we're aiming to be the end of silos. You don't have a storage system for Hadoop or a cluster for HPC, for your databases for OpenStack, but you run everything on a horizontal infrastructure. And to be able to do that, you need to support all workloads. That's mostly file, block, and also object, but you also have to have the performance to be able to do that. And the other benefit then, if you don't have the silos anymore, you have higher utilization, right? Your cluster, that's OpenStack cluster, is probably more idle during the night, can run a MapReduce to process data for analytics, things like that. And also automation, right? Google's running the whole storage stack with 2 on-call people, and that's many data centers and large clusters. So that's basically the goal, but as a storage startup, that's not where you start, right? You don't take telecoms clusters and replace their NetApps with Quobyte as a first step. Where we're starting is OpenStack infrastructure, because that's a very good fit, right? Software storage and OpenStack. Container storage as a file system, we're a great backend for containers, Mesos and Kubernetes clusters. As a parallel file system, we're also a very good fit for HPC. That works well. And then basically same architecture, different community, big data, parallel file I/O, locality, and things like that. The architecture is similar to ExtremeFS, although Quobyte is total redesign and rewrite, but that's one of the things that we kept. At the top are basically registry services. That's basically a 3 to 5 times replicated database with lookup services. configuration, monitoring, discovery, everything's in there. There's also a device database for example, in there, so the system knows all devices. Then a layer below are metadata services. You can start any number of metadata services. They're basically hosts. They're basically hosting replicated metadata databases, which are then 3 times replicated in a peer-to-peer fashion. So you could, if you have a large installation with, let's say, 10,000 file system volumes, you could spread them across like 20, 40, whatever the workload makes sense, metadata servers. And you can also do that dynamically, right? You can start with 3, add more, move, spread out the replicas and things like that. And then at the lowest layer, we have data services. That's basically where you store the bulk of data. They're taking the file data, and they're also doing peer-to-peer replication, which makes them very scalable. Or erasure coding. That's the 2 redundancy models there. So how does Quobyte look like when you use it? In the end, you have a /Quobyte on every host. That feels like a local file system or an NFS server. You can do anything in there. You can access all file system volumes there. And it's subject to quotas, scalable and everything. Those volumes are logical file systems, so per se they can have any size. There are no attached restrictions by the systems. But what you can do is add quotas to them, which can be per user group or tenant or volume. That's something where you can do resource management with. We have multi-tenancy support. The tenants are basically namespaces for volumes. So you can have a tenant customer 1 that has 10 volumes, then a customer 2, 100 volumes, and then your own volumes for your virtual machine images, for example, in a default tenant. The tenants are also usable for NFS. That's basically how we do the Manila integration. There you can basically specify, okay, this volume is only accessible to certain IP ranges, and that's controlled by the Manila subsystem, and then VMs can mount that and others can't access the data. As a unified system, we also have S3 proxies. Basically, the objects are stored as files into the file system, so they're basically subject then to normal file operations. And also for some access, NFS proxies make sense, right? For filers, because you don't need a client installation on your workstations, for example. Or VMware is also a thing which you can't directly integrate with. That's basically how Quobyte looks for the users. Management, we took great care that the management is simple of the system. One important part is that it's configuration-less services. So you just deploy them with a little file. There's a configuration file that gives them identity, but that's all auto-generated. They register in the registry database, and you can basically auto-deploy them or also just kill them, move them, and things like that. As I hinted to, the configuration is all in the registry databases. There's volume configurations. There is stuff like the NFS server configuration. But currently, actually, there's not too much configuration. It's a few things like quotas and so on and so forth, devices, placement. But it's not like a thing where you have thousands of knobs where you have to change things, right? One important part is that we're conscious of hardware. So we have integrated device management. We store serial numbers, make them available. We have per device monitoring. We monitor smart and so on. And the goal there is to really integrate into data center workflows, because in the end, it's physical servers with drives, right? And you need sometimes an audit log where drives have been, and to be able to find them later and things like that. And data center workflows, we think, are an important part of operations. One important design aspect of the system are the background tasks, or we call them maintenance tasks. These are things which automate stuff in the system. In Quobyte, there's nothing per se from the architecture, there's nothing happening automatically. What you need to do is basically either hook events to an automation task, to a maintenance task, or start them manually. Examples for those tasks are scrub, right? Basically, trigger reads of all data and verify the checksums. That would be one example. You can start that manually, but you can also say, okay, start that every 7 days, for example. Or device drains or replace, rebuild. You can do that manually, drain that, but you could also configure a rule saying, okay, if a server or if a device has had I/O or CRC errors for the last hour, then replace it automatically, right? These are things that, and you can also tie them to time of day things, right? If you're saying, okay, I want to make sure that this never influences my production workload, yeah, attach the rule to nighttime, and then it's going to be replaced at nighttime. And there can always be monitored and stopped. So it's just it's a first class concept. The system also has a built-in monitoring, which basically scrapes lots of metrics from all services, aggregates them, shows them in the web console, but they can also be made available for other monitoring systems. You have 3 ways to manage the system. One is, as I said, the web user interface. Basically, you can do everything there. We also have an API and a command line utility, so whatever you choose works there. So how does Quobyte work? I chose to make a comparison with Ceph as a base because people have this architecture already in their heads, and I would be asking anyway, how does it compare to Ceph, right? So let's start. Both systems are in the category of single point of failure, free storage system, split brain safe, and software architectures. That's something that not many storage systems have, and where you have to look really in detail if that's really true for all components and parts and things like that. The core structure of Ceph is an object store, but not your usual object store like a Scality or Amplidata or something like that, but it's with mutable objects. So Ceph can do basically change byte ranges within the objects. It's not write once. Which basically, no history on storage systems. Quobyte is at its core a distributed parallel file system, and that's basically the difference there. Then from the interfaces, Ceph has file, block, and object. For file, you have the little footnote that the CephFS is not ready yet, it's not production ready yet. For Quobyte, we're file systems, so file is no problem. A block we are mapping to files with which works pretty well. We also support objects via S3 proxy, which are mapped into the file system. But I wouldn't claim that you can use Quobyte to make competition to Amazon with billions and billions of objects. That's not what it will work for. You can use it to store, for example, for each customer like 10 million objects or something. That's great, and then 10 million for each customer or something like that. But it's not a large-scale object store. The storage unit in Ceph are objects. This is this Rados subsystem. They're, as we heard this morning, I think 4 megabytes default, right? Mutable and with CRC protection. I think that's server-side CRC. In Quobyte, it's file parts. They're much larger. Also mutable and with end-to-end checksums, which are computed on the client side and then are verified at various points in the lifetime. Failure detection, both systems to have the split brain safety, use Paxos algorithms. The big difference that in Ceph's case, this is done globally. You have those mons that basically determine the state of the system and enforce it. In Quobyte, nobody knows the state of the system. It's always a local peer-to-peer decisions, which has a few advantages. Then placement. Ceph doesn't have a metadata server. It does consistent hashing in a structured way, so you can configure things, but there's also a pretty wide spread of data always, which you can't control. Quobyte has a metadata server. A metadata server basically has a mechanism where it can decide via policies where to put parts of the files. And you can configure that policy engine, do a lot of things with that. Those decisions can also be changed. So while you're accessing a file, you can move data between, for example, hard drives and SSDs and things like that with full fault tolerance and no interruption, basically. It's an important part of the architecture. Parallel file I/O, basically in the HPC Hadoop kind of sense, is limited with Ceph. Quobyte from its HPC origins is a full parallel file system where you can run compute clusters on or larger map reducers. Redundancy, both systems to do peer-to or primary backup replications between basically elected primary server and backups. And both systems also do erasure codes. I think in Ceph they're working with some tiering layers and are computed server side. In Quobyte they're client side computed, and you basically do the parallel fan out to your devices. The hardware foundation, Ceph runs, or both run on commodity hardware. With Ceph you have recommendations around journaling SSDs, RAM consumption, and backbone network. With Quobyte, there aren't many restrictions there because the architecture is different. Okay, let's go through the architectural details. So file block object. What Quobyte does at its core is using files, and I already mentioned that basically objects are just stored as files in the file system. And we also do virtual machines as image files in the file system. Basically, you know that from a local virtual machine runs, you just have a QCOW2 or raw image file in the system, and basically use that. What's nice about that is basically all your data is available via the file system interface. You can do stuff like move data in via FTP server and then export it via S3, or back up your virtual machine snapshots directly from the file systems, things like that. What Ceph is doing at its core has Rados objects, and because they're mutable, it can map basically 4K blocks to those larger 4 megabyte objects and do in-place modifications. Ceph has native snapshot support at this layer and can do snapshots there. And it doesn't really have a limit on the number of objects, and that I think would make it a good candidate if you are looking for a large scale object store. One very important differentiator is the I/O path. With XperiFS and Quobyte, we developed a lot of insight and algorithms to be able to do basically replication with fault tolerance, but also do so while not needing any artificial extra things. With Ceph, to be able to do the replication, everything goes through a journal, and basically Ceph is doing journal-based replication like in MySQL. Quobyte doesn't do that. All I/O goes directly to the hard drives. So basically, if you have a certain I/O pattern on a logical file, you'll see the same I/O patterns with the same concurrency on your SSD or hard drives, which helps a lot in various aspects. So first, it doesn't have. You can have servers with like 60 drives and really use them. I/O doesn't go through the journal. So you have better scalability. There's no bottleneck. Because of the way the journaling works, you always have a RAM footprint. I think there's a recommendation of 1 terabyte of drives needs 1 gigabyte of RAM. We don't have that. We're not using much RAM on the storage servers. And so you can also run Quobyte hyperconverge, basically running Quobyte and Nova compute nodes on the same machines, and then also benefit from the locality of access there. The one-to-one pattern also vastly simplifies capacity planning. In the end, Quobyte, as any software storage system, has a certain overhead. There's a networking latency, and there's also a software overhead. But in the end, it scales linearly. So once you determine your overhead on your hardware, you can say, okay, double, quadruple the number of nodes or drives or whatever, and that's the performance you're getting. That simplifies things a lot. And then, probably last but not least, Quobyte, because stuff doesn't go through the journal, through the bottleneck, has a much lower latency. So customers measured 3 to 5 times improvement on latency and IOPS, which then in turn gives you a better performance for your money, right? You need fewer servers and so on and so forth. And you can also then run workloads that are probably not possible on a Ceph cluster. Ceph's journal also has advantage. It's because if something goes down, you just have to replay the journal, right? And you have very efficient recovery after downtime. I don't know, I've never ran it in production. I can only report on architecture, which I did a lot about. And yeah, okay. Okay. The placement aspect, I think I already mentioned a lot about it. In the end, the important parts is it can be changed at any time dynamically. You change your policy configuration, press the enforce button, and data is being moved according to the new policy configuration without basically stopping the world. You can continue to access the data. Things you can do with that. I mean, there's one important part is actually this policy thing, but because we're a file system, you can also, we're getting a lot of information. So you can do stuff like files are created on Flash, and then if they haven't been touched for a week or so, move them to hard drives automatically. That could be a policy, and every time you run the enforce, stuff is being moved. You can run just periodically at night, and then you're moving stuff. What else is there possible? You can treat. I mean, there's one customer running DACH where you have to append only files and the mailbox files, and the mailbox files are great. Or the append only files are good for hard drives, right? You just append. So you can configure the system to put this extension on hard drives, and the mailbox files, because you're doing random I/O, are good for SSD. So put this file on Flash. And basically, you just put that in a configuration, and then the data is spread accordingly. You can do, I already mentioned tiering. You can do partitioning. You can say, okay, we have this one customer that runs internal or external that has these 10 machines where they have hard drives and everything. We're managing their storage service, but the data must always go to their hard drives. And you can do that and restrict the placement accordingly. And then also locality, right? You can choose to if a file is created on the server that the client that requested the create is running on, and then the first replica is local. You have lower latency plus less bandwidth usage. We're also exporting the locality information in our Hadoop driver, so we can run basically MapReduce's Google style, where most of the I/O is actually local, not going over the network. Ceph is using consistent hashing with structure around it. That's great because you don't have metadata service. It reduces complexity. There's one component that you don't have to write. Although I think they do have metadata service for the CephFS, if I remember correctly. One problem with that, I think that's also what you alluded to, is that if the structure changes, data has to be moved, and that can be a lot of data. And yeah, that can basically really bring your availability down. Plus, you need a good storage backbone network to be able to actually move the data in practice. Failure detection and handling. With Quobyte, as I said, we don't have a central instance that knows anything about the availability. You have the dashboard. It tells you stuff is not available, but this is basically just information that has been derived from monitoring. There's nobody saying really, oh, it's not available, do this and that, and things like that. But what happens is when we do any I/O between the client and the server or between servers, we're doing the I/O, and if the network connection fails, the algorithms assume that's a server that's down or too slow or whatever, and handles that condition accordingly. But one server can look perfectly fine for one part of the system if it's an intermediary network problem. Other parts of the system might not be able to reach it, and they're treating that differently. And that brings quite some scalability, because we don't have this as global information, and also for basically hardware failures, or more specifically drive failures. You can do then a fully declustered rebuild. You just, if you replace a device, you can basically recreate the data from all other devices and recreate the data across the cluster. That's something that's, I think, a term that comes from GPFS, and it's pretty important if you have large hard drives, right? You don't want to recreate a 6 terabyte drive on another 6 terabyte drive, because that takes a day at least. Right. So this was a bit of comparison. I hope you have an idea. This stuff is not easy, as I said earlier. People have to dig into the architectural details, compare, and try it out and measure and look in there. There's no drawers like this workload is good for NetApp, so I buy NetApp, and that solves the problem for me. I think these times are over for a few years now. Quobyte for OpenStack. So we have Cinder drivers for Juno and Icehouse, and starting with the Kilo release, we're part of the distribution for Cinder and Manila, so we can do shared storage there. And we have Keystone integration. I'll go through the details later. On the roadmap, we're looking into supporting more Manila features. You can do stuff like placement there or export existing file system volumes. That's currently not supported, but not a big deal. And then we're also looking into supporting our fine-grained placement control better, that you can really, for example, co-schedule a virtual machine to a compute host where it already has a local replica, things like that, right? Also controlling, okay, these virtual machines should run on flash and these should run on hard drives, things like that. So how does our Cinder integration work? Basically, what we do is just run our client on all compute hosts. Basically, there's a /Quobyte conceptually on all compute hosts on Glance services. And that's where the image files and instance files are stored and accessed. So it's basically accessing data from all over the cluster. And that's then basically accessing Quobyte, and that can also be co-located on one machine, as I sketched here, or the Quobyte can be running on different machines as you like. We currently don't have any optimizations for Glance, so basically starting a virtual machine is fetching the image from storage and creating the virtual machine. You're benefiting from the parallel I/O there, so basically you can saturate your network, but there's no magic snapshot start a virtual machine kind of thing. Quobyte also currently doesn't have any snapshotting mechanisms for files, so you're just using the QCOW2 snapshot functionality. There's a lot of, what's the word, orally traded knowledge about QCOW2 being slow, but that's not really the case. Plus, any snapshot mechanism degrades performance, right? That's true in VMware, and that's also true if you do the thing in the source system. In the end, everybody has to do copy and write and lookups and things like that, right? So we chose to use QCOW2 for now, but are planning to include snapshot mechanisms, because for other use cases they're really useful. Right. So basically, that's the first point. So basically, how that works is the /Quobyte is a local Fuse client that makes the file available, and the virtual machine KVM QEMU just accesses that virtual machine image as you would do it with an image file on your local hard drive. And this has much higher performance than Ceph. That's not a problem. For Manila, for the shared file storage, we're exporting basically Quobyte volumes directly to virtual machines. How it works is we can have any number of NFS proxies. They're stateless, also configuration-less soon. basically they're configured via the registry, which tells them for certain volumes and certain tenants can only be accessed from certain IP ranges, and that can be done manually or via Manila. And then those volumes, for example, a /customer1, can only be accessed from one subnet or from another subnet. So you can do multi-tenancy and everything without much overhead there. It's all NFS. We also have Keystone integration in some sense. What we did is because Quobyte has basically a user management for the administration users that can log into the console, and that can also self-service tenants. We are basically providing, usually you do a local or LDAP backend there. We can also take Keystone as a backend for that. And then you do your user management in Keystone, and users can normally log into the console and administrate the system. We can both map the Keystone domains, that's I think the new concept, and projects, that's the older Keystone concept, to Quobyte tenants. And then basically currently we know 2 roles. Super user can do everything. That's for system administrators, and domain admins can then basically configure volumes of a tenant. You could export that to your customers. We can also, basically our S3 proxy is also interfacing to Keystone. We basically use it as a repository for the access keys and EC2 credentials, so that when a user comes via S3, it can authenticate and basically take stuff from Keystone to be able to do that. Basically Amazon style there. So that's it. I don't know how fast I was. But it's probably good to stop early if there are questions, right? We also have a booth downstairs, so you can also come later. Yeah. Live migration. What would happen then is that, so we support live migration without problems. What would happen is that the new host that doesn't have a local replica would access the primary overall over the network. Doesn't have locality then anymore. But it's transparent. Pardon? Currently, no. The primary election takes some care to be local to the client, but there's currently no mechanism to force it to another server. I think it would be doable, but yeah, that's a refinement that we haven't been doing yet. No, it's X4 or XFS. But it's a different journal. That's the local file system journal, and yeah, you can't get around that. But Ceph has a journal on top of that to be able to do replication, and it has that normally per what they call OSD, I think, and you can do that centrally to a server. But it's always a bottleneck for these operations. And they're also storing on local disks and then having the X4 or XFS journal. Yeah. Yeah. So we're always consistent, obviously, because it's POSIX file system semantics. So what we trade is availability. If 2 out of 3 replicas are not available, you won't be able to write anymore. How we handle that in practice is that the client is per default in a retry forever mode. So if a virtual machine runs on that, it's just stopping the world for probably a couple of hours, and then as soon as storage is again there, it can continue. Yeah. I think if you know XtremeFS, you'll see some concepts showing up again, but it's a complete rewrite and re-architecture. So yeah, lots of things are different. So we're a startup. We released version 1.0 earlier this year, and we're, I can say, probably pre-production with customers. So it's stable. You can run production workloads on it. Basically then we have the normal mechanism. So if you tell me later you want to try it out, you're getting access to it and can just download it. In the end, we have a repository with Linux packages for all distributions. You download it, put it in a couple of servers. It's very easy to install. Can be done in probably an hour or so, and then you can try it out yourself. So currently there's no community edition. That's probably something we would do at some point, but you want to. That's not nothing we should do early, I think. Yeah. So there's no kernel component. That's probably the short answer. Both servers and client is all user space. So we're pretty agnostic about distributions and kernel versions and so on. Yeah. In the end, it's an image file. Like QCO2 can also run VMs from image files, and that's how it accesses it. Yeah. System can do on files random 4K concurrent I/O, and there's no restrictions around that or problems. Yeah. I think time's up. Thank you very much. Can talk later.